So here's a couple examples of how the z-score helps us determine a situation. Let's suppose we're looking at people of the same age and we're looking at 14-year-old boys and we're testing their cholesterol. And so the average cholesterol is 170 and the step size, the variance, is 30. The standard deviation is 30. So levels above 240 may require medical attention. So drawing a situation here, the center is at 170, and we want to know where 240 is. Well, I know 240 is on this side, and I asked for more than. So I want to know the percent that fall not to the left, but to the right of 240. Well, I need to be able to look up a z-score. So to find that z-score, I see how far away I am, my observation minus the center, divided by the standard deviation size, which is 30, or my step size. Reducing this, I get 2.33, and I just rounded that. So I go to my table, I look up a z-score, notice it's positive because it's above, and I go to 2.33. So finding that on my table, 2.33, and this is where 2.3, but then I need to go over to the 3 and straight down, and I find it to be about 99%. So they're using this as a reference. If you had a child that was 14-year-old male, went in and had this cholesterol 240, 99% of 14-year-old boys would be less, and only 1% would be at 240 or more. So that would tell you that it's a very high cholesterol level. If we wanted to go between those two, again, you set it up. Here's the 170, here's the 240, and I want between those. So, and again, we need to transfer these into z-scores. This is a z-score at 0 because it's right at the center, and the 240 is a z-score, again, we found a 2.33. Well, I already know that 99% are less, or to the left, of 240. And I also know that 50% are less than 170. So what I'm going to do is subtract those, because I'm going to take off the area that was the too much business here. And it looks like when I subtract that, about 49% fall between 170 and 240. A situation in your book talks about IQ scores, and you want to know the average is 100. Getting that from this situation with a step size of 16. You want to know IQ below 84. So if I look, where is 84 on my table? Notice they drew that for me. So here's 84. So go ahead and find the z-score for that. 84 minus 100 by the step size. You're down 16, and each step size is 16, so you're down 1 standard deviation. If you look up 1 standard deviation in your table, notice it's a negative 1 standard deviation. Negative 1.0 is about 16%. So below is 16%. And that's what they were looking for. And how did I know that? Because it said below. So if it says less than or below, you're going to the left. Another situation, you want a score of 84 or more. Well, if you know that this is that 16%, this is going to be 84% because they total 100%. So if you know left, you also know right. And the proportion here, this word proportion means the percent. So now I want to know the percent between 84 and 116. Well, if this is symmetric, I know that this is 16%, so this must be 16%. How would I know that? This is 1 standard deviation above, this is 1 standard deviation below. And so when I take a look, let's see, 16 and 16, oh, I also know, since it follows a normal distribution, this better be 68%. Because if you recall in the normal distribution, between 1 standard deviation below and 1 standard deviation above, 68%. If I'm at 2 standard deviations, it's 95. And if I'm at 3 standard deviations, it's 99. Almost, we'll just round it to 100%. There's one more page of extra practice. that we'll look at. This has to do with the length of a human pregnancy. It averages 266 with a standard deviation or step size of 16, less than 246. So to find this, my observation minus my average, how much is that in a distance? So it's less than the average. So shorter term, deliver earlier, 266, 246 is on this side. How many steps did it take me to get down there? Well, if I subtract that, that's negative 20 with a step size of 16. Negative 20 divided by 16 is negative 1.25. So I go to my table. I look up negative 1.25. Negative 1.25. So it looks to be like negative 1.25 is about 11%. So I'm reading to the left. This is 11%. Did I answer my question less than? I did, 11%. If it had said more than, it would have been this side, which is 89%, because again, the total must be equivalent to 100%. In the next situation, we have the 240 to 270. So if I mark that, remember this is 266, which linear transformation would make that 0. 240 is on the left. 270 is just slightly bigger, slightly longer. 270. So I want to know how many people go a little above and some below. So I'm first going to take 270 minus 266 and divide that by 16. 270 minus 266 is 4 over 16, which is 1/4 or 0.25. Going to my table, looking up 0.25, making sure I'm on the positive, 0.25, 0.2, and we're going to go to the 5, which is about 60%. So this area right here is 60%, and we knew it would be slightly bigger than a half. Taking the 240 minus 266 over 16 would be 26 over 16, and notice that 26 is negative. 26 divided by 16, you're down 1.625. So looking at my table, down 1.625. Looking at the negative piece, down 1.625, negative 1.62 is about the best we can do, and that looks to be about 5%. And so this little piece is 5%. So if I subtract those two, I end up with 55%.